The next topic is polynomial function. For the first example, we're going to find the limits of 5x minus 10 as x approaches to 1. Through substitution method, we're going to substitute 1 to the x in the equation. 5 times 1 minus 10 is equal to negative 5, so the limit of 5x minus 10 as x approaches to 1 is equal to negative 5. For the next example, we're going to find the limits of x squared plus 4x as x approaches to 2. Again, through substitution, we're going to substitute 2 to the x in the equation. 2 squared plus 4 times 2 will be 4 plus 8 equals to 12. Therefore, the limits of x squared plus 4x as x approaches to 2 is equal to 12. For the last example, we're going to find the limits of x plus 14 as x approaches to negative 2. By substituting the value of x, we'll come up with the equation negative 2 plus 14. Negative 2 plus 14 is equal to 12. Therefore, the limits of x plus 14 as x approaches to negative 2 is 12.
Our next topic will be the limits of rational functions. The limit of rational functions is the number at which a rational function gets closer fx approaches b as gets closer to a certain value. Here is the first example. Lim x approaches to negative 2, x minus 4 times x squared minus 5 divided by x minus 2. And next, we are going to solve it. Lim x approaches negative 2x minus lim x approaches negative 2, 4 times lim x approaches negative 2 x squared minus lim x approaches negative 2, 5 divided by lim x approaches negative 2x minus lim x approaches negative 2, 2. Negative 2 minus 4 times 4 minus 5 divided by negative 2 minus 2. And the answer will be negative 6 times negative 1 divided by negative 4. And the answer will be 6 over negative 4. And the final answer will be 3 over negative 2 or negative 1.5. The second example is lim x approaches 3, 5 over 4x. Lim x approaches 3, 5 over 4 times lim x approaches 3x equals 5 over 4 times 3 equals 5 over 12. And the final answer will be 0.42. The third example is lim x approaches 2. 4x minus 1 times x plus 6 divided by x plus 4. 4 times lim x approaches 2x minus lim x approaches to 1 times lim x approaches to x plus lim x approaches to 6 divided by lim x approaches to x plus lim x approaches to 4. 4 times 2 minus 1 times 2 plus 6 divided by 2 plus 4 will be 7 times 8 divided by 6, and the answer will be 56 over 6 or 9.33 will be the final answer.
The next topic is the limits of radical function. For the first example, we're going to find the cube root of x squared plus 4 times x plus 6 over x plus 2 as x approaches to 2. By substituting the value of x to the variables in the equation, we'll come up with the equation cube root of 2 squared plus 4 times 2 plus 6 over 2 plus 2. Squared plus 4 is equal to 8, 2 plus 6 is also equal to 8, and 2 plus 4 is equal to 4. By evaluating the equation, we'll come up with the answer of cube root of 64 over 4. And by simplifying, we'll get 4 over 4 or 1. For the next example, we're going to find the limits of square root of x minus 1 minus 6 as x approaches to 5. Again, by substituting the value of x to the variables in the equation, we are now going to evaluate square root of 5 minus 1 minus 6. 5 minus 1 is equal to 4 and the square root of 4 is equal to 2. 2 minus 6 is equal to negative 4. For the last example, we're going to find the limits of square root of x squared plus x plus 2 over x minus 3 squared as x approaches to negative 2. We're going to substitute negative 2 to the x in the equation. After that, we're going to evaluate square root of negative 2 squared plus negative 2 plus 2 over negative 2 minus 3 squared. Negative 2 plus 2 is equal to 0, so negative 2 squared will remain. Square root of 4 over 5 squared is equal to square root of 4 over 25. By simplifying, it will come up with the answer of 2 over 25 or 0.08.
Exponential function. For example, number 1, the limit function as y approaches negative 1, e exponent of y is equal to e negative 1. Substitute the negative 1, then e is exponent of negative 1 is equal to 0.38. For example number 2, the limit function as q approaches negative 3, e exponent of q plus 1 is equal to e negative 3 plus 1 is equal to e negative 2 and is equal to 0.14. For example number 3, the limit function as n approaches 2, e exponent of 4 minus n is equal to e 4 minus 2 is equal to e squared is equal to 7.39.
The next topic is limits of logarithmic function. The first example is limit of x approaches 7 logarithmic x minus 5 is equals to logarithmic 7 minus 5. So the answer is 2. Logarithmic 2 is equals to 0.3. So the answer is 0.3. Example 2. Limits of x approaches 5 logarithmic x squared minus 9 is equals logarithmic 5 squared minus 9. So the answer is 1.2. Last example. Limit of x approaches 15 logarithmic x minus 9 is equals to logarithmic 15 minus 9. So the answer is 6. Logarithmic 6 is equals to 0.8. So the answer is 0.8.
The next topic is the trigonometric function. For the first example, we're going to find the limits of sine 2x over x as x approaches to 6. Through substitution, we're going to substitute the value of x to 6. By pressing sine 12 over 6 in the calculator, we'll come up with the answer 0.03. For the next example, we're going to find the limits of cosine x over 3x as x approaches to 1. Through substitution, we're going to substitute the value of x to 1 and press cosine 1 over 3 in the calculator and come up with the answer of 0.33. For the last example, we're going to find the limits of 3 times 1 minus tangent x over 5x as x approaches to 1. We're going to substitute the value of x to 1 and press 3 times 1 minus tangent 1 over 5 in the calculator. The answer will be 0.58. Therefore, the limits of 3 times 1 minus tangent x over 5x as x approaches to 1 is equal to 0.58.
Special function. For example, number 1, the limit function as r approaches 0, 2 minus sine 3r over 2r. Approaching to the left, r negative 1, negative 0.5, negative 0.1, negative 0.00, negative 0.0001. For the f of r, we have negative 1, negative 2, negative 10, negative 1,000, and negative 10,000. Approaching to the right, we have in R1 0.5, 0.1, 0.001, and 0.0001. For the f of r, we have 0, 1, 9, and 999, and 9,999. For approaching to the left, negative 1, negative 2, negative 10, negative 1,000, negative 10,000, which is negative infinity, and for the right is positive infinity. For example number 2, we have the limit function as s approaches u, cosine times 5s over 3s. Approaching to the left, s are negative 1, negative 0.5, negative 0.1, negative 0.001, and negative 0.0001. For the f of s, 0, 0, 0, 0, and 0. Approaching to the right, 1, 0.5, 0.1, 0.001, and 0.0001. For the f of s, we have 0 when we total it 0, and also approaching left 0, approaching to the right 0. Then the limit function as s approaches 0, cosine times 5s over 3s is equal to 0. For example number 3, the limit function as u approaches 0 is e exponent of u minus 2 and minus 1 over u plus 3 approaches to the left, u negative 1, negative 0.5, negative 0.1, negative 0.001, and negative 0.0001. For the f of u, we have negative 0, negative 0, negative 0, negative 0, negative 0. Approaches to the right, u 1, 0.5, 0.1, 0.001, and 0.0001. For the f of u, we have negative 0, negative 0, negative 0, negative 0, negative 0, which is 0, 0. Then, the limit function u approaches 0 is e exponent u minus 2 minus 1 over u plus 3 is equal to 0.
Lastly, we're going to talk about indeterminate limits. Some limits are called indeterminate if the limiting behavior of individual parts of the given expression is not able to determine the overall limit. If the limits are applied for the given function, then it becomes 0 over 0, which is known as indeterminate forms. To better understand this, I constructed some examples to guide you in solving indeterminate limits. So for the first example, we're going to find the limits of x squared minus 2x over 5x squared as x approaches to 0. To solve this, we'll proceed to substitution method and substitute the value of x to the variables in the equation to find its limits. Any number multiplied to 0 is also equal to 0. So 0 squared minus 2 times 0 over 5 times 0 squared is equal to 0 over 0, which is also undefined. For the next example, we're going to find the limits of x squared minus 1 over x minus 1 as x approaches to 1. As for what we did in the first example, we'll proceed to substitution method and substitute the value of x to the variables of the equation. 1 squared minus 1 is equal to 0 and 1 minus 1 is also equal to 0, which leads to the answer of 0 over 0, which is also undefined. For the last example, we're going to find the limits of x plus 3 over 5x plus 15 as x approaches to negative 3. By substitution method, we'll come up with the equation negative 3 plus 3 over 5 times negative 3 plus 15. And if we will evaluate it, we'll also come up with the answer 0 over 0, which is again undefined.